Hey guys, Avi here, and welcome back to our LangChain series. In this video, we're taking our LangChain knowledge to the next level. We're going to be applying LangChain and large language models to our own documents by loading and then applying a question-answer retrieval chain on our own information. This is going to be the most complicated video in this course, and it'll be pretty exciting. I'm going to try to give a high-level overview of all the concepts, but this entire video could be a course in of itself. So first thing first, in your shell, what I want you to do is, let me clear this real quick. What I want you to do is install two things. I want you to say python 3-m pip install. And then over here, I want you to install chroma_db. And then once you've installed that, I want you to install tick token. So again, the two things that we're installing are chroma_db and tick token. We're going to be needing both of these for our video today. And if you're not using Replit, feel free to install this in terminal or any sort of console that you're using. But the goal is to get these two packages installed. After that, we need a text file that we can import and ask questions on. So I know what you're thinking, like all the work that we've done so far has been using the generative AI components of what OpenAI and these models were trained on, like the vast corpus of data that exists on the internet. However, if the question was, how can I use LLMs with my own data, whether that's my textbook, ebook, financial PDFs, etc., that question hasn't been answered yet. And so again, that's what today's video is about. The text of choice that I have chosen for us to analyze is going to be the 2023 State of the Union. So over here, I just searched State of the Union 2023. There is this White House Gov link, remarks of Joe Biden. That leads us to this. And all I did was I copied and pasted this entire file into a TXT file. So this is what I did. Feel free to choose any TXT document of your choice. Go find a PDF that you've been reading or an ebook you just started. But the goal is to create a .txt file that looks something like this. I've called mine State of the Union-23.txt. It has the entire thing over here. And now in my main.py file, we're ready to get started with this file. So first thing first is going to be a series of imports. And while I could write each one line by line, I'm going to save myself by time and copy and paste all of them. So let's go through each one real quick. From LangChain, import OpenAI. We've seen this. This imports our OpenAI LLM. Document loaders import text loader. And then from text splitter, import recursive character text splitter. These two will be used to take our document, load it in, and then split it into chunks. Okay. After that, we have OpenAI embeddings. These embeddings help us measure the relatedness of text strings. Chroma is a vector database that we'll be using to take our document, get the embeddings, and then save them in a vector database for retrieval, which will be Chroma, which is locally run. And then last but not least, we're going to be using the Retrieval QA chain. The Retrieval QA chain will help us look up the relevant documents from our Chroma vector database and then ask the relevant question to that data, resulting in an answer. Let's dive right into loading in our document. Loader is going to be equal to text loader, and we're going to pass in the file path of our State of the Union 23.txt. I'm also going to go ahead and ignore the code intelligence real quick. Give me 1 sec here. So in settings, I don't like the pop-up that shows up. There we go. Now that we have our loader created, what we're going to go ahead and do is take in our document and load it in. So we're going to say here documents is going to be equal to loader.load. And for now, let's just print out documents. So if we print out documents, we should see here State of the Union-23, the entire text file that we have loaded into a document object. You can pass in multiple documents. Here, documents is going to be an array, but you can see right over here that this is the entire file of the State of the Union that we've loaded in from our text file. Now that we have this document, what we can go ahead and do is split this document into chunks, okay? Why do we need to do this? Why are we even splitting our documents in the first place? Well, you split the documents into chunks because if the text is too long, it can't be loaded into the model. You want to create these semantically related chunks, and all that means is sentences that are related to each other. The best way of doing that is by putting sentences that are close to each other, or words that are close to each other so that they're semantically related. And then what you go ahead and do is you can use this recursive character text splitter to split our large text into smaller chunks. So let's go ahead and do just that. Text splitter is going to be equal to recursive character text splitter. And then inside of this, we can specify two parameters, our chunk size and chunk overlap. So here chunk size can be 1,000 and chunk overlap can be 200. This again is pretty dependent on your use cases. You can play around with these numbers and figure out what's happening. But at the end of the day, what the recursive character text splitter does is it splits this large text by 3 recursions. The first recursion is the double new line. So it looks something like this, new line, new line. The second recursion is 1 new line. And then the third recursion is just a space. So you can see how it would break it down first by these paragraph splits, then by 1 sentence splits, and then finally by spaces between words. So that is what the recursive character text splitter does. And then after that, we can go ahead and create our list of texts or chunks by saying text splitter dot split documents, and then we pass in our documents right here. If I print out the first text, and let's say I also print out the second text just to show you an example, we can go ahead and see what this does in practice. So we take our massive State of the Union doc, and then we can print out these 2 chunks. Each of these chunks is a chunk size of 1,000. You can see how it starts off with Mr. Speaker, Madam Vice President, and it goes all the way to Nancy Pelosi. And in the second one, you can see how "and I want to give special recognition" gets repeated. And so you can think of the chunk overlap as a rolling window across paragraphs. In case there was some, relevant sentence that had to be part of both this and this, you can use the chunk overlap to have some overlap between every chunk that gets created to ensure that these paragraphs are still relevant. Now that we have our text created, we can now move on to creating our embeddings. So go ahead and say here, embeddings is equal to OpenAI embeddings. And I know what you're wondering, what are embeddings? So OpenAI has this beautiful function or this beautiful library of embeddings, which is simply a vast library of text embeddings. And each embedding here measures the relatedness of text strings. They're very commonly used for searching and clustering. And every embedding that you see is a vector of floating point numbers, where the distance between vectors measure their relatedness. In this OpenAI embeddings, there could be a word embedding, a sentence embedding, and it's essentially across multiple different factors, sometimes 4,000, 5,000 different factors. How are these sentences related and where do they fall in this mapping? For example, let's just go with a very simple example here. If I was talking about like animals, for example, cows, chickens, etc., these words in their vector form might be close to each other as animals, versus inanimate objects like cars or boats. They're transportation vehicles, and they might be close to each other. Similarly, you might see that the words that start with C, cows, chickens, cars, might also be closer to each other on a different axis. So the whole idea of embeddings is taking sentences, taking words, and mapping them to vectors. And then once you're in the vector format across a different wide variety of features, you can take new sentences, for example, our State of the Union 23 sentences or chunks, and then map them very similarly to this vast array of embeddings to figure out where do they fall, how are they related to each other. So we have our embeddings, which is our OpenAI embeddings, and now finally we can create our vector database to retrieve from and store our text on these embeddings. So we can say here, our vector store is going to be equal to chroma.from documents. So we're initializing our vector database chroma, pass in text, passing the OpenAI embeddings, and then we create a collection name for ourselves, which is going to be State of the Union. So what is Chroma? Chroma is an open source lightweight embedding database that can be used to store embeddings locally. In this entire example, what we're doing is we're taking our source document, which is the State of the Union, we're splitting it into chunks, which make it easily parsable and inputable into our OpenAI model. We then generate embeddings for each chunk. OpenAI has done this for the entire corpus of the internet using all the sentences, and then we can simply generate similar embeddings for each chunk. And then once we have these embeddings generated for how similar are these sentences on all these different axes, then we can store all of that in our local Chroma database. Now we have this vector database, which is a collection of all these vectors on these different axes. And now we can go ahead and query from this database using our retrieval QA chain. The last thing that we now need is to create our LLM and initialize our retrieval QA chain. Go ahead and pass in over here, temperature as 0, and then go ahead and say chain is going to be equal to retrieval QA, where our chain type is going to be LLM, and our retriever is going to be using our store as retriever. All we're doing is we're saying, okay, retrieval QA chain, go ahead and use the vector database that we just created, this Chroma store, as your database, and then perform Q&A type question answer retrieval using this database. The retrieval QA chain looks up relevant documents from the retriever and then passes those documents and the question to our QA chain to return a response. We can simply run this chain now on a simple question. We can say chain.run or print chain.run. What did Biden talk about Ohio? After running this command, we can see exactly what gets printed out. Biden talked about the Brent Spence Bridge between Kentucky and Ohio over the Ohio River, the $1.6 billion for the project, meeting an iron worker named Sarah, etc. This is all relevant information about Ohio. So how is this working? Well, remember, what's happening behind the scenes is chain.run is being called on this question, this prompt, what did Biden talk about Ohio? This question is then used to retrieve the relevant documents from our vector database. So key points here would be like Biden and Ohio, and then you find the relevant documents from our vector database that have high similarity searches or similarity scores with words like Ohio or words like Biden. And then once all those documents are retrieved, then we're simply taking in those documents, taking in this question, and then using all that information just like a normal LLM would do to generate a response. And so this is the ultimate response that was created. That was a very high level overview of document loading and QA retrieval. I think you can very quickly see how this could scale to your own use cases, whether it's financial PDFs, whether it's Excel spreadsheets, documents that you're reading right now. What you can very easily do is load them up, create chunks from them, create and embed them into a vector database, and then perform this Q&A type conversation style where you can query information from your relevant documents and get the result using a large language model. Thanks so much for listening, guys, and I'll see you in the next video.